Hi everyone, welcome to another video on test automation architecture design. This video will discuss the topic about understanding SUT technologies and how these interconnect with test automation solutions in chapter 3 of official ISTQB advanced level syllabus of test automation engineer certification. We will discuss access levels to the software under test interfaces and will explain them one by one with brief examples. We will also discuss paradigms of interaction and try to explain each of those paradigms and considerations in paradigm choice. So now you might be wondering, why is accessing test interfaces is so important for automated test execution? Well, it's simple. You need some sort of access to the software under test to run your test cases. If you don't have access or have limited access, you won't be able to successfully complete test execution. Imagine the system under test as the engine of a car and the test interfaces as the key to start that engine. In automated testing, test interfaces serve as the gateway for our test automation system to interact with the SUT. Without access to the test interfaces, our test automation efforts would be akin to trying to start a car without a key. We simply wouldn't be able to efficiently engage with the SUT to validate its functionality, performance, or behavior. Accessing the test interfaces allow us to send commands, retrieve data, and simulate user interactions within the SUT environment. This level of access is crucial for executing automated tests efficiently and accurately, whether it's at the software level, API level, protocol level, or service level. Each access point provides us with unique opportunities to interact with the SUT and verify its compliance with our test criteria. So, in essence, understanding and accessing these test interfaces is like having the master key to unlock the full potential of automated testing. It empowers us to streamline our testing processes, increased test coverage, and ultimately deliver high quality software products to our users. Let's now discuss the access levels. First up is the software level. This means our test automation systems are directly linked to the software of the SUT. Imagine it like controlling a video game character with a joystick. We have direct control over the actions and behavior of the SUT's software. For example, automating a login process on a website by interacting with the login form directly. Next, we have the API level. Here, our test automation systems interact with the SUT through its programming interface. We are sending commands to the SUT's API to perform specific actions. For instance, testing a weather app by sending requests to its API to retrieve weather data. Moving on, there's the protocol level. This is where our test automation system communicate with the system under test using protocols like HTTP or TCP. We are using predefined rules, protocols to exchange information with this system under test. For example, testing a web server by sending HTTP requests to retrieve web pages. The last one is the service level. A test automation system interacts with the services provided by the system under test, such as web services or RESTful services. It's like ordering food from a menu. We are utilizing software under test services to perform specific tasks. For example, testing an e-commerce website by placing orders through its checkout service. Each of these access levels offers its own unique way of interacting with the software under test, allowing us to effectively automate tests and ensure the quality of our software products. Paradigms of interaction comes into picture when test automation system and software under test are separated by APIs, protocols, or services. Remember the software access level, the first one which we have discussed on previous slide, where both software under test and test automation solutions are both linked directly. When this is not the case, the test automation engineer need to decide on the paradigm of interaction. There are three types of paradigm. We will discuss each of them separately. So first we have the event-driven paradigm. In this paradigm, the interaction between the test automation system and the software unit test is driven by events exchanged on an event bus. Think of it like attending a concert where the performers are the software under test and the audience members are the test automation system. When a performer, you can say SUT, starts playing music, it triggers an event, for example, a song, that the audience test automation solution responds to by clapping, dancing, or cheering. In automated testing, this could involve monitoring user interface events such as button clicks or page loads and triggering tests based on those events. Next, let's talk about the client-server paradigm. Here, the interaction between the test automation system and the software under test occurs via service invocation from service requesters to service providers. Imagine you are at a restaurant where you, the test automation system, place an order with the waiter, the service requester, who then communicates your order to the chef, the service provider. The chef prepares your meal and sends it back to you through the waiter. Similarly, in automated testing, the test automation system sends requests to the SUT to perform actions or retrieve data, and the SUT responds accordingly. Lastly, we have the peer-to-peer paradigm. In this paradigm, the interaction between the test automation system and the software under test occurs via service invocation from either peer. Picture two friends having a conversation where they can both initiate and respond to each other's messages. Similarly, in automated testing, both the test automation system and the SUT acts as peers, where either one can initiate communication and exchange information as needed. Each of these paradigms offers its own advantages and considerations depending on the nature of the SUT and the testing requirements. By understanding and choosing the appropriate paradigm for interaction, we can design more efficient and effective automated test architectures. Let's discuss what needs to be considered when making a choice about the paradigm for your test automation architecture. Choosing the right paradigm for interaction between the test automation system and the system under test is crucial. The paradigm choice depends on the SUT architecture and may have implications on the SUT architecture. It is not just functionality, it also depends or it also impacts the overall architecture of the SUT. This means our choice needs careful analysis and considerations to ensure a future-proof architecture. Understanding the ins and outs of the SUT's in technologies and how they mesh with the test automation system is absolutely crucial for getting automated testing right. When we take a good look at the different ways we can interact with the system under test and how they fit together, test automation engineers can make some very smart decisions. These decisions pave the way for solid test automation setups that run smoothly and effectively. It's all about building a stronger foundation for testing that can stand up to the challenges of the software development as it evolves. And this concludes our topic. Thanks for watching the video. Please like, subscribe to stay updated on the similar content. See you next time in another video on software testing.